So I hope you at least tried these on your own, or at least a couple of them. If you can get some, I'm impressed with that because I don't really expect you to remember everything from algebra. But let's get started with these. I'm going to start with ones that are similar first. So I'm going to start with the trinomials. So anything with three terms, I'm not going to exactly go in order because I think it's easier to split it up by type. So this is a binomial, something with two terms. So I'm going to skip that. I'm going to do all the trinomials first. So my method for trinomials is I can always try a greatest common factor, and then I can try reverse foiling. Those are our two methods from the page before. So first of all, is there a greatest common factor? Is there a biggest number that goes into 1? Which is not written here. If the coefficient's not written, it's a 1, a 5, and a 6. Well, 5 is prime. Its only factors are 1 and 5. So there's not going to be a biggest number I can pull out. And between x squared x and then it not having an x at all, there's not a least power of x that I can pull out of anything. So this is definitely not going to be a greatest common factor problem, but we can try it since it's a trinomial. So my only other method that we have in this course is going to be reverse foiling. So that's where I multiply to be 6 and I add up to be 5. So I'm going to make my parentheses that we're going to do for reverse foiling. We're going to have an x and an x, and now we're going to think of what type of factors we have to have. So I want to add up to be a positive 6 and multiply to be a positive 6 and add up to be a positive 5. So multiplying to be a positive 6 means I could have a positive times a positive or a negative times a negative. So I want to have something that's either two positives or two negatives in order to multiply to be a positive, but I have to add up to be a positive 5. So if I want to multiply to be a positive and add up to be a positive, I have to have two positives. Otherwise, two negatives are going to add up to be a negative. So I have a positive times a positive to multiply to be 6 and add up to be a positive 5. So what are my factors of 6? I could have 6 and 1, but 6 plus 1 is 7. So it's not going to add up to be my middle term, even though it multiplies to be 6. So instead of 6 and 1, we could try 2 and 3. And 2 plus 3 is 5. So that works. So x plus 2 times x plus 3, because positive 2 times positive 3 is positive 6, and adds up to be a positive 5. So I'm going to look for something that's just like this one. So I'm going to look at my other trinomials and think about the ones that have a positive at the end. So I'm going to skip over to letter E. I'm going to go by type instead of by order. So over here, I have to multiply to be a positive 20 and add up to be a negative 9. The only other thing I could do before I reverse FOIL is try a greatest common factor, but there's no least power of x to pull out between these, and there's no biggest number that goes into 1, 9, and 20, because the only thing that can go into 1 out front is 1. So I'm going to go ahead and reverse FOIL. I'm going to multiply to be a positive 20 and add up to be a negative 9. Doing some reverse foiling here means I can put in these parentheses with my x inside. So I want to multiply to be a positive and add it to be a negative. So I must have a negative times a negative to multiply to be a positive and add it to be a negative. It can't be two positives because then it'll add up to be positive like the problem before. So I have a negative times a negative. I just want to run through the factors of 20. So if I had negative 1 times negative 20, that would multiply to be a positive 20. But negative 1 plus negative 20 is going to give me a negative 21. So that doesn't work. So if I try negative 10 and negative 2, that would work for multiplication, but negative 10 minus 2 or plus the negative 2 is going to give me a negative 12. That doesn't work for my middle term. So next I could try negative 5 and negative 4 would multiply to be a positive 20, and negative 5 minus 4 is going to be that negative 9. So that works. So you have x minus 5 and x minus 4. Some people call this guess and check because you really are guessing some numbers and then checking that it works. So it can be lengthy depending upon how many factors go into the number. So 20 had more factors than 6, so it took a little bit longer. All right, so let's go to another trinomial. So we have two trinomials left. So let's go back to this side. We'll look at C. We want to add up to be 4. And multiply to be a negative 45. We could try a greatest common factor, but again, the coefficient on this is 1, so I can't pull out a biggest number, and there's not a least power of x because this term doesn't have an x. So we can't do a greatest common factor, even though it's okay to try for a trinomial. So reverse foiling, I actually like this type a lot better because I don't have to think about, is it two positives or two negatives? If I'm multiplying to be a negative, it is always a positive times a negative. So you have an x plus and an x minus. So a positive times a negative, and I want it to add up to be a positive 4, which means my positive number is going to be the bigger factor. So factors of 45. Definitely don't want to do 45 and 1 because positive 45 minus 1 is going to give me a positive 44, which is not even close to 4. Some other factors, I could do 9 and 5. So again, I want to add up to be a positive. So 9, the bigger number, would be the positive one. 9 minus 5 is 4. So 9 minus 5 is going to add up to be 4, and multiply 9 times a negative 5 is going to be negative 45. Perfect. Our last trinomial on this page is over here. So we want to multiply to be a negative 40 and add up to be a negative 6. I want to add up to be a bigger number, or add up to be a negative number, which means the bigger number is going to be the negative 1. So I'm going to put in my parentheses. Again, there's no greatest common factor for this one because we have a coefficient of 1 out here, and then we don't have an x on this last term, so we can't plot a big number or a least power of x. So I'm going to multiply to be a negative 40, which is awesome because that's automatically a positive times a negative to multiply to be a negative. And I want to add up to be a negative 6, which means the bigger number is going to be the negative 1. So I could try some factors of 40. I could do negative 40 plus 1 would be negative 39, so that doesn't work. Other factors of 40, I could do 20 times 2. So if I had a negative 20 plus 2, that's not going to work. That's negative 18. So maybe negative 10 and 4. Yeah, negative 10 plus 4 is going to give me the negative 6. So negative 10 plus 4 is negative 6. Perfect. All right, and lastly, we're going to go over to these binomials, these ones with two terms. So my light went out here. My two-term binomials. So we have these two-term binomials. And the first one, we have 16x squared minus 100. So one thing we could do is we could try to take out a greatest common factor because 4 goes into both these, but there's not a least power of x to take out. So you could take out a 4 and that would be totally fine. And we can see where that goes. The other thing I could do is also check if it's a difference of two squares. So maybe on this one, I see 16 and I see 100. I'm going to recognize that these are square numbers. But taking out greatest common factor is also fine. I'll show you that solution in a second. So I want to think about what gets squared to be 16x squared. Well, 4 squares to be 16, and x squares to be x squared. So you have a 4x getting squared to give you 16x squared. And then minus what squares to be 100 is 10. So this is going to factor to be 4x plus 10 times 4x minus 10. There's my difference of two squares, and that's one way to do it. If you wanted to pull out a greatest common factor, I'll show you that up here. This is probably not how I'd do it because I would recognize that there's a difference of two squares, but if I didn't, I could pull out a 4 from both of them. So I'd have 4 times 4x to be 16x squared, and 4 times negative 25. Ooh, I need a squared on that x. 4 times 4x squared is going to give me 16x squared, and 4 times negative 25 gives me a negative 100. And then I would recognize that I could continue to factor this because 2x squared would give me 4x squared, so I'd have a 2x, and then a 5 would square to be 25. So you could do a difference of squares with this. 2x plus 5, 2x minus 5. So there's the other way to do it. Probably not the way I would, but it would be okay to pull out the 4 and then recognize that you have 2x and 5 for a difference of two squares later on. Either answer is perfectly okay though. Lastly, my other binomial, I could pull out a greatest common factor or try a difference of two squares. 6 is not a square number and 24 is not a square number. So I can't do difference of two squares. I have to do a greatest common factor. So what's the biggest number that goes into 6 and 24? Well, does 6 go into 24? Yes, it goes in 4 times. So I can pull out a 6. And what's the least power of x? X cubed or x? I can pull out an x. So 6x times x squared will give me 6x cubed for that first term. And 6x times a negative 4 will give me a negative 24x. And hey, we have a difference of two square numbers here. So I'm going to factor again, because x is getting squared and 2 is getting squared to be 4, so it would be x plus 2 times x minus 2. And that is the extent of factoring in this class. That's some of the hardest things that we'll do as far as examples. You've seen the hardest factoring that it can get.